Hello, everybody. It's January week 2, and it's the Deephaven community team back with a couple of demos. So let's get started. All right, first up, we got Matt. He's going to show us a comprehensive demo of the column grouping API.
Yeah, so this is a feature I've been working on for a while that allows you to group columns visually together in the UI. So you can create columns via layout hints. So here I have the list of groups that I'm going to create, and then I'm adding these to an existing table. This is the table is just from one of our Parquet examples. Um, and so these groups can be nested in any way. The only restrictions are that the names have to be unique from the column names in your table, and the names also have to follow our typical column naming convention. You can assign colors. These are just colors that are from our color module, but you can also assign any hex code as a color that you want. And so if I run this code, what it's going to do is create these groups, or these two tables. The first is just the table without any groups, and then this is this same table with some groups automatically created. So you can nest groups as many levels deep as you want. There might be some limitations on how useful that actually is, but you can nest as many levels as needed. So within the grid UI here, you can reorder columns within a group, but those will be limited to stay within that specific group. So if you drag something, it will move past entire groups. You can also move the entire group at once, and you can also hide or resize columns just as you normally would, and that will adjust the group as well. So if you want to do more, you can, aside from doing it in the layout hints, you can also edit these in the sidebar. So you can create groups from a selection. So let's say instead of having this group of times, I want to make a group of pickup information. So I can select this pickup date time and this pickup location ID, create a group, and then I can just call this pickup info. It'll create that group, and I can assign it a color. These are just some colors that we've picked from our style palette, but you can also assign any color that you want to this group. So then I could also add like a drop-off group with the drop-off info. And then if I wanted, I could select these and make a bigger group that's maybe ride info about this data. You can edit any existing group names. So these groups that I had before, I could change the names. Maybe I just want this to be called indirect instead of indirect costs. And these can also be rearranged. The difference with the sidebar is you can drag columns in and out of groups. So maybe I don't want this tip amount to be in the costs tab. I can just drag it outside of the group. You can do that with multi-select, so you can select anything that you want and drag it into an existing group, or you can move it outside of the group. You can also move selections up and down with these buttons here at the top. So as you move this up, it will move it up through the different, let me show this on the grid so that you can see what's happening. As I move this up, right, it'll move this vendor ID column into the top parent group. And if I move it up again, it moves it into this next nested, and then starts moving it through all of the possible locations. You can also move items to the top or bottom if you want to do that. Searching, you can search on column names or group names. So if I search for like costs, this will bring the first hit is this costs group, so that brings into view. If you sort, it will sort all of the columns recursively. So By that I mean it will sort the top level columns and groups alphabetically or reverse alphabetically, and then within each of the groups, it will sort its children alphabetically or reverse alphabetically, just depending on, and it'll do that all the way down. So you can see if I sort alphabetically here that within costs, you have direct costs and direct total amount is in alphabetical order, and then within each of those child groups, those columns are also in alphabetical order. And I think that's just about it. You can also, so if you were to select a group and then you can deselect items with control click, so add and deselect like you would expect, or shift click to select an entire selection. You can move like just portions of a group out of it. And then if you want to redo it back to the original state, you can reset, and that will reset your table back to whatever groups were defined via layout hint. And that's about it.
Very cool. Lots of functionality there. All right, next we have Corey. He's going to demo a first draft of the remote Python user API.
Yes, and so I would start with a couple of disclaimers. What this is, the goal of this is to take our existing kind of working C++ client library and leverage it by calling it from Python using Cython's technology, Python to C. And so what I'm going to demo is that a bunch of that functionality is working. With the disclaimer, a lot of the code that I've written doesn't look very Pythonic. You know, it has kind of Java-like looking names and so on. So try not to get too, offended by that. This is really to demonstrate the functionality more than the API being like exactly right. So with those disclaimers, let me show you my window. And the other thing that I want to say is I've got a bunch of small demos that I'm going to do really quickly in a row here, and each of them does a little bit of a thing, and then they kind of add to each other. So in this first one, my first demo simple is literally this little code here that's going to connect to the Deephaven server and then make a table and then print that table. So no biggie, but this is kind of the protocol that the C++ uses. You make a so-called client, you make a table handle manager, and you make a table handle. It's a little bit of ceremony that may not exist in the final version, but that's how it looks for right now. And we're making a very simple table of 10 rows with the numbers 0 through 9. And hopefully, when we run that, Python, it'll kind of work as advertised. Yeah, and there it is. So there's the column name, and then there's the numbers 0 through 9. So my next demo, I think it's print ticking, goes to the slightly next level where I don't make a static table, I make a time table. This number is 1 billion, so it's one. It ticks every second. It has the same contents, and it only keeps the last 10 rows. And what's new here is that I subscribe to this table using Python, and I give it a Python class. And that class looks like this. In this first version, that class is very simple. It's got 2 callbacks: what happens on error and what happens on every tick. And that ticking case is the interesting one. And I would say, without telling you yet what's inside this ticking update, currently we are just going to print the entire table on every tick. This true means column headers. This true means I want row numbers just for debugging convenience. And so there's another very simple program, but you can kind of see a little bit cooler than the previous one because it makes a ticking table and then prints the whole table every time. And you can kind of see that happening. It'll get to 10, but because I did a tail of 10, you can see my table gets no larger than 10 rows. So that's working fine. And then, but then my next demo is demo print deltas, I think. Ooh, not quite enough screen. Oops. I'll make my window a little larger. Still printing. This is pretty much the same preamble as before, kind of printing stuff. But in this case, instead of printing the whole table, I'm going to look inside my ticking update object. And to the extent that there are removes, adds, and modifies, I won't go into the exact syntax here, but to the extent that these are messages from the Barrage protocol, I'm going to print like the actual contents of the change messages coming from the server. And so what we will see here, hopefully, is like an add. There's an add, and these are just printing the deltas, by the way, printing like a textual representation of the deltas. And then by the time it gets to 10, you will start seeing, like I'm going to hit Control C here. Because I'm doing a tail, you will start seeing messages like this. That's, oh, I got a browse message where I had to remove row 0, and here are the contents of that row 0 that are removed. And then I added a new row 9 at the end. You know, everything kind of logically shifted up one, and I added a new row 9 at the end, and this is the contents of that row 9. So this is kind of proof that, you know, the Python code is getting these messages back and can look at them. My next one involves, now that we've, I know I'm going a little fast, now that we've been able to print these things, now we should, what does code look like when you actually want to read data and process it and pick through it? So I have demo read chunk. Another, it's getting longer. Let me see if I can scroll up just a little bit. Well, I guess the font size is pretty big. It fits. Okay, whatever. So what I want to show here is that you can, when you get an update, the job of this program is to take the whole table and to compute the sum of all of the values in that column. And this is just to show how that works. And it's in kind of Deephaven style in the sense that, you know, I make a chunk out here. I allocate a chunk, which is, in this case, it's a NumPy array. I also can work with Python arrays and actually any Python thing that supports the memory view interface. And I do this thing. This is a little different from standard Deephaven syntax, but you know, I get the row sequence of the whole table and I process it a chunk at a time. And I have these kind of fancy pants like computer science operators, take and drop, where take is like, oh, of your row sequence, take the first chunk elements and store it in this temporary variable called these rows, and also update that variable to kind of chop off the first chunk size element. So in other words, if you had a chunk that was like, if you had a bunch of rows that was like this wide, take and drop kind of work in parallel. Like take is the prefix and drop is the suffix, if you see what I'm saying. And so anyway, this little loop here is meant to take things a chunk size at a time, fill their little buffer, this Python buffer, add the numbers in that buffer, and then just print it out. Oh, it prints out the whole table, and then it prints out the sum. And this is my first big footnote. You know, this is not, as has been pointed out to me, this is not exactly a Python-friendly interface. I think a Python user might very much prefer to see this coming back as chunks coming from a generator, a so-called Python generator. But you know, that's okay. Part of the design of this is like there's this core functionality, and we can put Python, in fact, pure Python code on top of this to export a public interface to the user that can be just as friendly as we need to, in my opinion. So I would say don't worry too much that this looks more like, you know, Corey Kosak's private version of some Java vision rather than what Python programmers look. I get it, but this is kind of how it looks at this instant. Oh, and I should run that. This is still the same table, but if I say Python, it should start printing sums, and they should start increasing. You know, according to like Euler's formula, it'll start increasing until it reaches 10. But then, as we start getting modifiers, the sum's going to start. Anyway, whatever. This number is the sum of this table. Sort of take my word for it. And my final demo actually is quite a bit larger. What I was going to do is show that this kind of works. That this kind of works in the large. And what I do, you know, I have a table that has 1,000,000 rows in it, and all 1,000,000 of those rows change every second. And I was going to kind of show that the code still keeps up. And I'm going to show the source code first. Demo processing ticking. Basically, and this is going to look a little complicated, but basically the reason it looks it's long. Basically, I'm going to go from the inside out. The reason it's like a little longer than the previous ones is that this thing This is code that basically listens to a table, keeps an updated running sum dynamically, and updates that sum like no matter what happens to the table. So if there are adds, it sort of adds those values to the running sum. If there are removes, it subtracts those values from the running sum. And if there are modifies, it'll kind of subtract out the old value and add in the new value. And without necessarily going into a lot of detail, basically you can see what's the logic is that when a tick happens, you're basically calling this process delta's helper method with this kind of parity argument. You can sort of see, without going into detail, like if you give it the removes and you give it a -1, the logic of the routine I'm about to show you will effectively subtract out those rows. And if you give it the adds and you give it a +1, the logic of the routine is going to add those values. And in the modifies, you're going to see sort of both. You're going to see take the data before modifying it, subtract it out, take the data after the modify, and add them in. So I won't go into the precise details of that syntax, but I will drill into the process delta's routine itself. It's going to look a little similar to what we had before. We had chunks. We made a NumPy array. This is a 64K chunk. We had a NumPy array of the data type in 64. And this kind of like take and drop loop that I showed before. Take n values from the row sequence, fill the chunk with those n values, calculate a sum. Here's the little trick where I'm either multiplying it by +1 or -1, depending on whether I kind of want a net add or subtract. And then print it somewhere. Oh, I think I printed here at the top. Oh yeah, I print here with statistics after I've called process deltas a bunch of times, how many adds, removes, and modifies there were, and what the sum is. So to demo that, I'm going to go quickly to my other window. I'm going to hopefully connect to Deephaven. Oh, let me present my other window. Where are you? That might be very small.
Yeah, you'll want to enlarge the font size a little.
Yeah, gotcha.
That works too.
Is that good? Or
Yep. Yeah, that's great.
okay. And so this is the query. Oops, not that one, not yet. This is the query I was talking about, where I'm basically ticking every microsecond. I'm making random values from 1 to 1,000, 0 to 999, really, and then I'm bucketing them with I mod a million, so that my table tends to stay, will have basically size 1,000,000, doing a last by to kind of enforce that. So if I were to run this little query, hopefully I will see a table which does have 1,000,000 rows, but the point is they're all changing. Every single row is changing. Because I'm running every microsecond, basically every row is going to be changing every second. So, and then I'm also going to calculate the sum of that server side just as a sanity check. You can see it's this number that's kind of hovering around 500,000. And the reason it's not exactly 500,000 or 500 million, the reason it's not exactly that is, of course, because I'm using random numbers. So, on average, it's going to be somewhere around 500 million. So then if I run my, I go back and present my other little Python window again. Hopefully, when I run this code, Python demo process ticking, and voila! So it's getting 1,000,000 modifies. It's got this number here. To prove that this number is correct, I can see it's correct on my screen because I can see both windows. I could switch back if you don't believe me.
I'll take your word for it.
Okay, but it's actually kind of fun to see that both sides are actually calculating the same number. And that's it. End of demo.
All right, very cool. And that's all we have for this week. So we'll see you next week for another demo. Cheers.